Okay, so let me just say about 3.4 is what we're going to cover today. 3.4 can be a little tricky. And so, and they actually have two main topics, and part of it bleeds into 3.5. So as far as, so here's what I think I'm going to do. 3.4, there are two things. One of them talks about Z-scores, and then one of them talks about quartiles. I'm not going to cover anything about quartiles today, and so that will not be on the test. We're going to save that for the next test. So as far as today, we're going to cover, I'm going to say half of 3.4, and we're going to do a lot of problems because it just seems like people, this stuff about Z-scores that we're going to cover today, hugely important, and people don't learn it well enough and they'll miss it on the test. So I'm going to spend a lot of time on Z-scores. I'm not going to spend any time on quartiles. I'm going to save quartiles for 3.5, which is going to be on the next test. It's not going to be on this test. So half of 3.4 and 3.5, I would have put that all in the same section, but anyway, I didn't write the book. So anyway, as far as the test this week, so we're going to cover 3.4 today. We're going to have a review tomorrow, and then the test will be on Thursday. I'm probably going to, I haven't written the test yet, but I'm probably going to give you a minimum of 90 minutes because I know, especially like on that group standard deviation, and we're also going to do manual standard deviation. Those are going to take a little bit longer. So I am going to give people about, I haven't decided, 3 to 5 points extra credit. If you take it, like I will open the test at 8 o'clock, just like our normal class. I'll let you go till about 9:30 probably. And then you have until 10, between 9:30 and 10 to upload it. If you can upload your exam by 10, I'm going to give you, here I'm going to be nice, I'm going to be generous. I'm going to give you 5 points extra credit. Now, if some of you may have a class after, or whatever, you can't take it at 8, I will have it open all day. I'll probably end at about 11:30. You have to be in by midnight. So that you don't have to take it during class. But people who do take it during class are going to get a little bit of extra credit. So any questions about this week or the test?
Yeah. I was wondering, I would like to be able to take it earlier in the day, and I don't have
earlier
a class
than 8?
before. Do you think you could, like, I was thinking 7:30. I mean, I get up and ready by then generally, so.
You want me to open it at 7? I could do that, I guess.
I would appreciate that. Thank you.
Okay. I'll open it at 7 for Anna the early bird. That wasn't Anna, right?
It was Whitney.
Oh, Whitney. Oh, you're a ventriloquist too. I thought it was Anna talking to me. All right, Whitney. I'll open it up for Whitney.
Yeah, that actually helps a lot because I have a class right at 9, so it'd be nice to start earlier and still like qualify for that extra credit.
Okay. All right, I'll open it at 7 then. Any other questions?
How long do you think the test will take?
I'm giving you an hour and a half. Well, I'm giving you an hour and a half to take the actual test, and then you have 30 minutes after that to upload the test. Some of you I know have trouble. So basically what you're going to do is you're going to take your phone, you're going to take a picture of your test, and then you're going to put it in a Word document, and then you're going to save that. So, yeah. Some of you will get done faster. If you get done slower, then you're in trouble. Any other questions?
If we send it as a PDF rather than a Word document, is that going to make it more difficult?
No, that'll be fine. PDF or Word document. Here's what I would prefer. Some of you I know aren't super tech savvy, and you send me, if it's a 5-page test, you send me 5 pictures. I would prefer to avoid that. Please put all 5 pictures in a Word document. If you want to save it as a PDF, that's fine. I do know some people have a thing called Can Scanner or something. But if you could put them all in the same document, it just makes grading a lot easier for me. So, any other questions?
Yeah, do you know how many questions are going to be on the test?
Haven't made it yet.
Okay.
I would estimate 15 to 20, but it could be more, it could be less.
Okay.
It all depends. So, any other questions? I got one last thing. It will be, so your quizzes have been almost exclusively multiple choice. There will be, I would estimate, no more than half of the test will be multiple choice. There will be some, but like that quiz we did today about the group standard deviation, guaranteed that will not be a multiple choice. You will have to show your work. And those show your work problems will probably be worth a lot more than the multiple choice ones. So the test will probably be a lot more like the homework, where it's just show your work. Okay. By the way, is there anybody who does not have the book yet? Yay. All right. Okay, so let's go over 3.4. Now, here, I'm going to give you a quick overview. We're going to be talking mostly about Z-scores. I'm going to go over this formula in just a minute. There's 2 Z-scores I'll show you. At the end, where they're going to talk about percentiles. I am not going to cover this. I'm going to save this for 3.5 because it really belongs in the section 3.5. It doesn't belong in this chapter. And I want to make sure that you guys understand Z-scores really well. Okay. Now, and in fact, let me go back to, do I still have it open? Hopefully I do. Okay, so, okay, you've got your random number table and then you've got your Z-score table. We're going to be getting very acquainted with this table, with this here. This is going to be essential, not only for this class, but also for the rest of the semester. This is going to be a table that you're going to become intimately familiar with. Okay. Now, this says this is the standard normal distribution. Now, basically, let me make sure. Here we go. Whoops. Okay, so we've got a bell curve. Now, the standard normal distribution is special. Okay. A lot of people ignore that word standard. They just blow right past it. No, standard normal distribution. The mean in the standard normal distribution, mean is always, and I'll even put that in capitalization, always 0, and standard deviation is always, what happened? Why am I not typing? Always, it won't let me type. Always 1. I don't know why that wouldn't let me type. Okay. So, and I want to just emphasize again, a lot of people blow right past that word standard normal distribution. Now, there's lots of distributions that are normal, but we're talking about the standard normal distribution. And so that's this table here. This is the standard normal distribution, okay? So the mean, as you guys know here, I can't make the letter mu very easily, so I just say mu for mu. But it's that Greek letter. If we go back to the formula sheet here, remember, and you can, I will emphasize again, you not only you can, but you should print this out before you take the test. And you can use any of these formulas on the test, okay? This is the Greek letter mu. Mu represents the population. This is the American letter X bar, X with the line on top of it that represents the sample mean, okay? And sigma, once again, represents the population standard deviation. S represents the sample standard deviation, okay? So make sure these letters here are very important, okay? Standard deviation is squared is S squared, that's also called the variance, and sigma squared is the population variance, okay? All right, so who remembers the 68, 95, 99 rule, or the empirical rule?
That states that when you're 1 standard deviation away from the mean, then that's 65% of the population. When you're 2 standard deviations away, that's 95% of the population. And when you're 3 standard deviations away, that's 99.7%.
Perfect, okay? All right, now that's going to be very important, okay? So I don't know, who said that? What was your name?
Emily.
Emily, good job, Emily. She said it perfect. So 68% within 1 standard deviation. I said 68, no, 86. 68% within 1 standard deviation, 95% within 2 standard deviations, and 99.7% within 3 standard deviations, okay? Now, there are 2 ways to do these problems, okay? There's the empirical rule, which I've got in red, and then there's the other way, okay? So any normal distribution can be converted to and I want to put standard in capital letters so you don't ignore it, normal distribution with the formula, and I'm going to copy it because it'll be easier to copy. It's going to be, so they've got the population z-score and the sample z-score. Actually, you know, I'm going to go to my notes here because I'm going to be a little bit different here, okay? But here's the formula, z equals x minus mu over sigma, okay? Now, this formula can be used all tests, all during chapter 3, okay? In the future, I'm going to be giving you a very similar formula that looks like this. It's x minus mu over sigma over the square root of n, okay? Now, when we get to that future chapter, most students are going to say, how do I know which formula to use, okay? And I'm going to tell you, always use this one, okay? In fact, let me copy this. Let's see how well this copies. Maybe I'll get lucky. Oh no, I didn't get lucky. Oh, I'm not gonna get lucky. Anyway, I'm gonna say use this one always, because you can use this one in chapter 3 and it works fine, and then you can use this one. So here's the rule. I'll write this on here. In this chapter, let me just say it this way. If there is an n in the question, use it. If n is not mentioned, assume n equals 1, okay? So that's going to be the rule, okay? So this chapter, I'll give it away. In this chapter, n is always 1, and if n is always 1, these two formulas are identical, correct? Okay. So what I'm going to try to do, even though you won't learn this semester or this chapter, n is always going to be 1, and I just want you to get used to using this formula, and then you only have to worry about one formula. Does that make sense? Okay. All right. So now, what's nice is So we refer to this as normalizing the data, as you convert it to a standard normal distribution. So as I mentioned earlier, the mean is always 0, the standard deviation is always 1. So the question is, who had a better score? So Jenny scored 600 on the SAT exam. Her friend Gerald scored 21 on the ACT exam. The SAT is normally distributed with a mean of 500 and a standard deviation of 100. The ACT is also normally distributed with a mean of 18 and a standard deviation of 6. So what's nice about this formula, either this formula or the other one, okay, is we can convert both Jenny and Gerald's scores so that they're on the same scale, and then we can compare and see who did better, okay? So let's see here. So let's find the z-score for Jenny, and we're going to convert her score, and we're going to put them both on a standard normal distribution. Remember, with the standard normal, we're going to convert both of their scores so that the mean is going to be 0. Okay, so who do I want to pick on? I think Alejandra, I don't pick on you near enough. Can you help me figure out the z-score for Jenny?
So first you would find the midpoint of both of them.
What do you mean by the midpoint? We're going to use, here, I want you guys to get used to this one. This chapter, you can use this one, but I want you to get used to this one, okay? So we need to figure out what is the x, what is the mu, what is the standard deviation, what is the n. So for Jenny, what is the x?
600.
600. Okay, Jenny scored 600 on the SAT exam. We're going to subtract off the mean. What is the mean for the SAT exam?
500.
500. So that's the numerator. Then we're going to divide by sigma. What's sigma? What's the standard deviation on the SAT exam?
100.
100. And we're going to divide by the square root of n. How many Jennies are there in this problem?
1.
Yeah, so we're going to do the square root of 1, okay, which is just 1, right? Okay. So remember, in this problem, the reason why they're getting rid of the square root of n is because n is always going to be 1, okay? But I want you to get used to using it because n will not always be 1 in every problem, and then this will be the better formula, okay? All right, so if we do a little bit of math, 600 minus 500 is 100 divided by 100 equals 1.0. So she is exactly 1.0 standard deviations above the mean. Okay. All right, so now let's talk about the table here, okay? Now this table, you guys are going to have to memorize this table. No, I'm teasing. Okay, so the thing that I want to pay attention to is it's shaded to the left. Now, let me just show you another table that you don't need for this chapter. But this is what we call the t-distribution. It's shaded to the right, okay? So it's important to pay attention. And remember, just look at this and make sure you know, is it shading it to the left or to the right, okay? Now, the way that Jenny did this, okay, here's how we're going to use this table. This tells you the area to the left. Now, Jenny's actually, if this is 0 here, Jenny's score is actually above the mean, but whatever, okay? So the z-scores, you can have positive or negative z-scores. She scored 1.0, okay? So the way this works is this gives you the first decimal, and then up at the top of the table, it gives you the second decimal. So I wish I could put all these on the same page. This is 1.00, 1.01, 1.02, etc., etc. 03. So there's, anyway, so this is 1.09, okay? So she got 1.00, so that means she scored better than 84% or 0.8413. So she scored in the 84th percentile.
So on a test, will this table be given, or is this something we can print out as well?
Okay, so that's what I said at the beginning. Please print this out today. If you haven't printed it out, you're going to use this on the test and on quizzes. This whole thing. So if you wanted to, if you really, I would just print it out. I know it's like 9 pages long, but we're gonna cover all this stuff. So just print out the whole thing, and we will use this on all tests and quizzes. So yes, print it out today if you don't have it, and you will be expected to use this on the test, or if you prefer, you can memorize this whole table. Who would prefer to memorize the table? Okay, good job, Alexander. Okay, all right. Okay, so she scored better than 0.8413 of the other students. Okay, does that make sense? Okay, we're going to try to do a few more of these. Okay,
so
now
the X is the number of, I mean, so on this one it makes sense because there's only one person, but there's multiple people. I mean, what is X again?
so another way to think about this is data minus the mean. That's your numerator. It is so huge. Data minus the mean over the standard deviation over the square root of n. So that conceptually, that's what this formula is. So you've got your data, whatever your data is that you're measuring, minus the mean over your standard deviation over the square root of n.
So like in this equation, or in this specific problem, you'd actually have to run the equation twice because one for each set, each data
Exactly.
point.
Now, in fact, we're going to do that right now. We're going to find the z-score for Gerald. Okay. Do I have a volunteer who would like to help find the z-score for Gerald?
And,
Say your name when you're the volunteer.
oh, Alex Lawrence.
Alex, good job. Okay, so how would you find the z-score for Gerald?
First, you take X, which is his score on the ACT, which is 21,
21.
minus the mean score is 18, and divide that by the standard deviation of 6, divided by the square root of n, which is 1. So you can forget about it, I guess.
Okay, so 21 minus 18 is 3 divided by 6 equals 0.5. So he is a half a standard deviation above the mean. Okay, so if we were to plot these on here, let me go back to here for a second. Okay, now, so Jenny scored right here. Okay, and now we've got Gerald, who's going to score right here. So visually, you can see here, you can already, to answer the question, who did better, you can visually see who did better, right? Based on just the z-score. I don't even need to figure the table out. Who did better based on the z-score?
Jenny.
Jenny did. Okay. Now let's also figure out how Gerald did. So he's 0.5 standard deviations above the mean. What percentile did Gerald finish in?
We're just assuming it's 0.50, which
Correct.
so 69% above.
Yeah, it's that number right there, right? Okay. So he's in the 69th percentile, 69th percentile. Scored better than, and I know we always like to convert these, but leave those as a decimal. 6.6915 better than other students. Okay, does that make sense? Okay. I was hoping to do one or two more of these. Okay. All right, so here's another example. Who had a better year, the Yankees or the Phillies? Okay. Now, just so you know, some of you are not baseball fans, which is a sad thing. I don't know why you would not watch baseball, but in the American League, the pitchers do not hit, and so typically they score more runs than the National League. The Phillies are in the National League, so they're going to score fewer runs because pitchers hit and they don't do as well. So the idea is we're comparing two different leagues, the Phillies and the Yankees, and we want to know who had the better year. So let's find the Z-score for the Yankees. How about, let's see here, Victor, do you want to do this one? Are you a Yankee fan, by the way, Victor?
I don't watch baseball.
Oh, I'm sad to hear that. But if you did, you'd hate the Yankees, right? The Yankees suck. Okay? Just so you know, I'm a Red Sox fan and we hate Yankees. All right, so how would you find the Z-score? You can look at this as the thing.
Okay, so what would be the X?
Oh, I'm asking you. That's your question. You're supposed to tell me. Oh, you know what? I screwed up.
How do you screw up?
Oh, well, something's wrong here because the X and the mean are the same thing. Let me see what here. I have to pull up this question here really quick. I'll fix my problem. Oh, they have the Cincinnati Reds. I guess we haven't updated this. All right. The Yankees scored here. We're going to update this problem. 859 runs. This is the old book. Oh, this is way different. 721.2 and a standard deviation of 93.5. And we're going to change this to the Reds. And the Reds scored 790 runs. And where the mean, actually scored 790 runs, where the mean was 721.1. And the standard deviation was 58.4. Big of a difference. Okay. Now I've updated the problem. Okay. So how would we figure this out?
You would do the 859 runs for the X, and then
Okay.
you subtract that from the mean of 721.0. And then you divide that by the standard deviation of 93.5. And then I guess you could divide by the square root of n.
How many Yankee teams are there?
1.
Only one. That's a good thing. Okay. All right. So if I plug this in, because I don't know those answers very well, plug it in my calculator. Oh, I don't have Excel open. Oops. Okay, so that gives me 1.47 standard deviations above the mean. Okay. Now let's do the same thing with, how about Zach? Are you a Cincinnati Reds fan, Zach?
Baseball is just kind of my least favorite thing, so
Your least
I don't
favorite.
really care either way.
Okay. So, do we have any baseball fans in here? Raise your hand. Keaton. Okay. Thank you, Keaton. All right. Can you find the Z-score for the Reds, Zach?
So what you would do for the Reds is to find the Z-score, you take their score, which would be 790, and then you subtract the mu, which would be 721.1, and then you would divide that over 58.4 divided by 1, just because n is equal to 1.
Right. You can see why they got rid of the square root of 1, because it gets boring, right? Okay, so based on this number, so we're going to do this one here. And so they are 1.179 standard deviations above the mean. So who did better? Let's answer that question with Rayleigh Anderson, because you look like a baseball fan. Are you? No? Okay,
No,
well,
I'm
even if
not.
you're not a baseball fan, you should be able to tell who did better.
The Yankees.
Yankees? That sounded like a question. Was that a question?
Well, it's just yeah, they did better because on the
That
table
was
it
better.
should
That
be.
was more confident. Yankees did better. Okay. Now, so that's correct. So Yankees did better than what percent of teams? Okay. Now, here's what we're going to do. We're going to round this to 2 decimals. So that rounds to 1.48. So can you figure that out for me? They did better than what percent of teams in the American League? How would you figure that out?
Can you pull up the table real quick?
Don't have that memorized yet?
No, I didn't.
Okay. So I know you can't see the top up here, but this is 1.40, 1.41, 2, 3, 4. What was the number we had? 1.48.
7.
5, 6, 7, 8. So they did better than what percent of teams?
93.
93% of teams. Okay. So the value on there, and if you want to put 0.9306, just leave those decimal basically on the tests and quizzes. I'll have you just round that to 4 decimals. Okay. And here, let's pick on Keaton since you are a baseball fan. Are you a Reds fan? No, not a Reds fan. Who's your team?
The A's mostly.
The A's.
Yeah.
All right. Okay, so we're going to round this also to 2 decimals here. So that rounds to 1.18. Reds did better than what percent of teams? So this is 1.18. Okay, so how do you do that?
I gotta pull up the chart. Let's see, 1.18.
0, 1, 2, 3, 4, 5, 6, 7, 8.
So yeah, it would be 0.88.
0.8810. Okay. Okay. So 88% of the teams. Okay. All right. So, all right, we're not going to cover anything else as far as the other percentiles on there. Do you guys feel confident that you could use the chart? Actually,
Yes.
wanted to do a few more problems on that. Now, here's the one thing that I do want to caution you guys on. Well, here, I'm going to change. We'll just do this with the reds, okay? What percent of teams did better than the reds? How would you figure that out?
You just take 1 minus whatever
Exactly.
they did. So it'd be
1 minus that number right there. So you could say 11.9% of teams did better. Okay? So remember, make sure, so pay attention to this. Do you want the white area or do you want the blue area? So you'll have to use the chart accordingly. Either way, you're going to get, so you basically your z-scores will round to 2 decimals, your areas will round to 4 decimals, and just make sure that you subtract it from 1 if you want the higher the white area versus the blue area. So, any questions before I let you go? Okay. All right, so I'm going to work on getting a quiz and homework for you today, and a review, and we can go over the review. So remember, it's going to cover a lot of information, chapter 1 through 3.4, and chapter 1 probably is going to be more multiple choice. Chapters 2 and 3 are going to be more show your work.
I do have one question.
Okay.
Will we ever be asked to first find the popular standard deviation, or population standard deviation from a group data, and then using that find the z-point?
From group data, potentially, it could happen. Yeah.
Cool.
In this chapter, they're going to probably give you the standard deviation and the mean most of the time. So you're less likely, but yeah, potentially you could. Any other questions? All righty then. Okay. Well, I'll see you all tomorrow.
Thank you.
Mm-hmm.
Thank you.
You're welcome.